Hi students, today we're going to take notes on the correct way of making a ratio table. So let's get started. Please label the top of your paper ratio tables. You know, I like my little bubbles. We're going to start off by defining ratio again. I know you've heard this several times, but it's always good to reiterate. A ratio is a comparison of two or more quantities. Now we're going to define a ratio table, since that was what we're going to be focusing on today. Okay, and a ratio table can be defined as a diagram. It is a type of diagram that's used to show equivalent ratios between two or more quantities. So today, since you've had a little bit of experience with ratio tables, I'm going to show you three specific examples. Okay, so today we're going to talk about three examples of how to make a ratio table. All right. The first example is going to be about how to make some purple paint. And you've already had some experience with that from last week. But we're going to start off with what we know, and that is to make a diagram. Okay. That's to use a picture. So this will be like a visual display. Okay. So let's pretend that we're making purple paint, and the recipe is, we're adding red and blue paint together, of course, but for every 5 parts of red paint, there are 2 parts of blue paint added. Okay, so we can actually write that nice ratio sentence. For every 5 red, there are 2 blue. All right, so now we have that nice discrete diagram that gives us a picture, but we're going to transfer that information into a table, which is actually, I believe, more useful to us. So this type of table that we're going to make is actually going to look like a T-chart. So I'm going to make a T-chart like this. Okay, and you can make your table like into a box chart, but today I'm going to do a T-chart. Of course, I'm going to have a label of red and blue. And I'm going to start with our original recipe, so to speak, which is for every 5 red parts, there are 2 blue parts. Now from here, I can scale up this recipe by multiplying my original recipe times 2. So I can multiply it times 2. And when I do that, I'm going to end up with 10 parts red to 4 parts blue. I can scale up my recipe yet again, as many times as I want. Times 3, I can scale it up times 3. So that would mean we would have 15 red and 6 blue. But on the same chart, I can also scale down. So I can go ahead, each line of this chart, I can change it to whatever I want. So I could go ahead and I could scale down this chart, so I could divide by 2. I could divide by 2 here. So 5 divided by 2, as we know, is 2.5. 5, and 2 divided by 2 is actually 1. So this would be an example of a scaled down and the rest of these up here are examples of how we can scale up. Okay, we can scale up. All right. So let's take a look at our second example. For our second example, we're going to actually make a recipe. And in this recipe, it calls for 3 cups of orange juice to every 2 cups of coconut water. So this is a drink recipe. So first I'm going to make a diagram, a discrete diagram again that shows us some pictures. So we're going to say for orange juice and coconut water, for every 3 cups of orange juice, we have 2 cups of coconut water. So here is our discrete diagram, which we're now going to transfer into a table. Okay, so I'm going to make a T-chart again, just like this, for my table, and I need to label my parts, orange juice to coconut water. Okay. Our original recipe says that for every 3 cups of orange juice, there are 2 cups of coconut water. So if I wanted to make a second batch, okay, of this, I would multiply times 2. This is the original batch, okay. So this 2 times 3 would be 6, and 2 times 2 would be 4. So if I wanted to make a second batch, I would need 6 cups of orange juice to 4 cups of water. And if I wanted to make yet another batch, so it would be a third batch, I would multiply the original recipe times 3, which would be 9 cups of orange juice to 6 cups of water. For our third example today, we're going to talk about some M&Ms, okay? All right, so let's say for every 4 red M&Ms, we have 2 orange M&Ms. So I'm going to make my discrete diagram with my pictures. So for every 4 red M&Ms, we have 2 orange M&Ms, which frankly I'm happy about because I like red better than orange. This time I'm going to make a T-chart table, but I'm actually going to turn the view of it for you, okay? So I'm going to show you that you don't always have to make a box table or a T-chart table. We can also turn it and it can look like this. So watch me make this type of table. And you really get to decide which one you like best or which one fits the information best. Okay, so this time I'm going to put red here, and I'm going to put orange here, and we have the original, the OG recipe, which would be for every 4 red, we have 2 orange, right? And then if we want to add another batch of M&Ms, okay, so if we wanted to add a second batch of M&Ms, then we would multiply it by 2, as you know. So we would multiply 4 times 2, which is 8, and we would multiply 2 times 2, which is 4. And of course, you know, we could go ahead and add a third recipe, and that would be 4 times 3 is 12, and 3 times 2 is 6. And we could scale down too, okay? We could scale down. We could divide by 2. We could actually scale down, so we could divide by 2, so we could scale down the recipe. So if I take 4 and divide it by 2, that's 2. And if I take 2 and divide it by 2, that's 1. So this would be an example of how you could scale down the recipe. Okay? So here are 3 different ways that you can make charts for representing information about ratios. Make sure that you go ahead and complete these notes, take a picture of them, and upload them for me to take a look at, and then add this to your math folder if it's not already in your notebook. Okay, I'll see you guys soon. Have a good one.